Aloha and welcome. Our next video is going to be on the selection sort. So let's go ahead and open up our textbook here. So a selection sort is essentially a sort that's going to treat the input as two parts. One is going to be the sorted part and the other is going to be the unsorted part. So the unsorted part you can think of as to the right, and the sorted part is going to be to the left here if you're talking about an array. So we're going to take a look at the algorithm for going through this. So the way we do it, if you look at the code here in blue, we're doing this through one outer loop that's going to go through every element of the array. Then we have an inner loop. And that inner loop, first of all, we're going to set index of smallest to that first one in there, the 0th element. And then we're just assuming that that is the smallest element to begin with. Then we're going to loop over everything past I. We're going to go I plus 1. We're going to go through the rest of the array. Okay, so once we do that, as we go through the rest of the array, we're going to say, hey, is this value less than the one at index smallest? On the first go through, that index smallest is going to be that first element there, the I equals 0 in this in the first case. So we're looking back here, we're saying, hey, is the number in this point of the array less than the number over here? In other words, it should be sorted down. If it is, then we say, hey, okay, let's take the index of this. We're going to say that's the index smallest now. Okay, let's look at the next array, element there. Is that one smaller than the one at index smallest? And then we would compare those. And if it is, then we say, okay, the index here is the smallest. We're identifying what the smallest one is after. And then at the end of this process, after we've identified the smallest one, we go and we swap. And we swap the ones. First of all, we say, okay, temp equals numbers of I, because we need to move the value that's at number at our first thing there. We need to move that into a temporary holder so it doesn't get overwritten. Then we say, okay, numbers at I, the one that we just assigned to temp, numbers at I is going to be equal to numbers at the index smallest, the one that we identified as being the smallest one. So after we've done that, we've set the smallest one there, and then we're going to say numbers of index smallest equals temp. So the one that was, so we're essentially swapping the places. So you've got now in the first position, well, you can say that on the first time through, that would be the first position, but really it's going to be when you take the unsorted, the sorted and the unsorted, it's going to go into the last position of the sorted part. So it's going to move it over to there at the end. So you'll have the the lesser things up to the point that you just moved over. You just identified the next smallest thing. So you put it over there, and then you took the value that was there and you swap it with wherever it was in the rest of it. Do you understand that? So again, this takes a bit of reading through to understand, and I'll go ahead and start the participation activity here so you can see it visually as it goes. So the selection sort treats the input as two parts: the sorted part, which is going to be theoretically to your left, and the unsorted part, which is theoretically to your right. It's using variables I and j to keep track of those two parts. So I is going to represent the right hand side of the sorted array, and j is going to represent its position within the unsorted. So we see here I equals 0 to begin with, and then we're going to start with j equals I plus 1. So you can see that right here, the element in array of 0 is 7. The element in 1 is 9. So let's go ahead and hit play. So the selection sort algorithm searches the unsorted part of the array for the smallest element, index smallest, stores the index of the smallest element found. So it's going to be looking through there. You see it's going through them one by one to say, hey, is this smaller than the one from index smallest? Is it? And it goes and it gets through everything here, and it finds that the element 3 is going to be the one that it moves down. So it's gotten to there. So then we're going to go and swap the two values as I mentioned before. We're taking, we're using this temp variable to do the swap. We're moving what used to be in position 2 here, moving it down to the position 0. So that's 3, and we moved 7 over there. These still aren't in order, but this whole left side is unordered. It's not in proper order yet necessarily. So the right-hand side is now in order. So this is the I equals 0 position. So then we do another loop, and I is going to be equal to 1. So indices for the sorted and unsorted pairs are updated. So we go to the I plus 1 and the j, which is going to be I plus 2 essentially at that point. So we're starting here, and we're looking through this, and we repeat that whole process again, and we compare them. So we're looking at the smallest index here. Is this one smaller? Yes, it is. Is this one no? Is this one no? So we know now that we need to take this value and move it. So to do that, we take the thing here, move it to temporary, swap the two values essentially. Now we have the first two elements sorted. So then we just repeat this over every element that's left. We keep going until we've finished out the entire thing. Then we swap. And then we do one last final one. We do end up swapping these two, use that temp to do the swapping, and we're finished. So this is how the algorithm works for the selection sort. And the way the reason it's called a selection sort is that it's selecting each one there. It's selecting it from the smallest one from the unsorted and moving that into the smallest, which is going to be to the right-hand side of the sorted array. So as it mentions here in an explanation of the algorithm, the index variable I is denoting the dividing point, that the point where we divide our sorted from the unsorted. Elements to the left of I are sorted, elements to the right are unsorted. All the elements in the unsorted pair are searched to find the index of the element with the smallest value. Then we take the variable index smallest, stores that index, the smallest element in the unsorted part, and then once the element with the smallest value is found, the element is going to be swapped with the element at location I. Then the index I is advanced one place to the right, and the process repeats. So the term selector, it says, comes from the fact that for each iteration of the loop, a value is selected for position I. So when we get into here, looking at that, assume selection sort's goal is to sort in ascending order. Given the list 0, 8, 7, 6, 5, what value would be in the 0th element after the first pass over the outer loop I equals 0? So if we're going through the I equals 0 one, and you go back and you look at your algorithm here, then given 9, 8, 7, 6, 5, you're starting out I is equal to 9. Then you're going to be going through what will be in the 0th after the first pass. So after the first pass, you should expect that 5 is going to be in the 0th element. And then it's going to ask you more questions about this. How many swaps will occur, during the first pass of the outer loop? Given the list, blah, 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 what will be the list after completing the second outer loop operation? So yeah, that'll be the I, so go ahead and calculate that. Here it gives us the entire algorithm, and we kind of already saw this before. This is almost exactly what we saw up above. So you've got the algorithm laid out again. And it talks about the order here. So when you're thinking about this, you've got an outer loop that's doing n number of passes, then you've got the inner loop, which is going to execute essentially well, actually, the outer loop is going to be n minus 1 times it's executed, and then the inner loop is going to execute an average of n over 2. So the total number of comparisons are going to be it's equivalent to n minus 1 times n over 2, and that gives you an order of n squared. So the order of n squared is going to be important when you're trying to calculate some of the things following this. So it also mentions that other sorting algorithms out there involve more complex algorithms but have faster execution times than this. So this isn't the fastest thing out there. And again, it gets into asking you questions like when sorting a list of 50 elements, index smallest will be assigned to a minimum number of, and you have to go in here and look at it. And remember, you're setting it how many times as you go through here. So you have to check, and if you know how many times you're going to pass through here, You can see that, and then you've got to calculate it, because every time you're going through there, you're assigning that. So that should inform your answer there. Now, the how many times longer will sorting a list of 20 elements take compared to sorting a list of 10 elements? That's where it comes to knowing the order. So if we're doing 20 versus 10, 20 squared is going to be 400, and 10 squared is going to be 100. So 400 versus 100, that's going to give you a multiple of 4 times. So that's how you calculate that. And down here, the same thing. Just remember that you're looking to figure out the order. So you take 500 square, compare it to 50 square, and that'll give you your answer. Then selection sort down here. When using selection sort to sort a list of with 13 elements, what is the minimum number of assignments to index smallest? So go ahead and start. So you know you're going to be assigning it every time through. So if it's 13 elements, you would expect 13. Oops, sorry. Actually, it's not 13. It's going to be one less than 13 because n minus 1. So remember that's n minus 1 on the outer loop there. So, or on the inner loop, sorry. Hold on. So if we're dealing with n minus 1, or for 6, we're dealing with 5. So yeah. So a list of, and it explains it down here, a list of 6 elements causes 5 outer loop iterations because the outer loop iterates from 0 to 6 minus 1. So you're going to assign it 5 times. So pay attention to that. It's really comes down to understanding, how this loop up here works. But go through this. What I want you to do is I want you to concentrate on the code and understand in your mind what it means. So when you're going through this code, kind of try to break it down in your head to the steps. So understand that this right here means, hey, we're going to loop over the entire array. And as we're doing that, we're setting the first one to index smallest, and then we're setting it to I, and then we're going to loop over the things after I to the end. So we're going through this process over and over, and all we're going to be saying here is, hey, is the value here at this place, is that less than the value found at wherever we have index smallest set? It's set to that I, which is the divider first off, the first of the unsorted, essentially. So it sets it to I in the beginning, and if it finds one that's lower, then it's going to say, hey, the index is actually over here now. So after you've done that, you adjust your index smallest, and then you loop again. You check the next element. You see if is that one, smaller than the one we just identified. And you go until you find the smallest one in the unsorted part. And then after you do that, you get to the next part here, which is where you're reassigning it. So the temp equals numbers just gives us a place to put that so we don't lose it when we do the assigning two numbers or numbers of I. So we take that, we assign it the new smallest thing, then we go to wherever that smallest thing was, and we swap and put that the original numbers of I in there. So hopefully that makes sense. If it doesn't, because I know this can be kind of hard when you're reading through code, if you have any questions about that, just reach out to me. I'd be happy to help you out. Just send me an email. I can set up a Zoom link, meeting with you. So anyway, I'm enjoying all these neat gestures that keep on coming up automatically. I'll turn that off for the next video. But until the next video, have yourself a good day. And again, reach out if you need help. Aloha.